Welcome to Periodic Table 101. My name's Chad Houston. This is a quick little tutorial on one of my favorite topics, the periodic table. It also happens to be February 7th, which, by the way, is National Periodic Table Day. Who knew? So anyway, this is a great resource. This is ptable.com, which is what you're looking at. What I would encourage you to do is take notes, but I would print out or hit pause, print out a periodic table, and then go ahead and take notes right on that. Quick little background, in the 1890s, there were many of these elements, not nearly this many, but many of them that people had and that had been discovered. Everybody was trying to arrange them in some way, shape, or form, but what would happen is that then they would discover new elements and they'd have to rewrite their table. Mendeleev was a young professor at St. Petersburg who over the weekend was writing a textbook, or not over the week, but on one particular week, he was finishing his textbook. He knew he had to do something with all these elements. He then put each one on cards with their properties, and he decided to arrange them based on properties. And what he found was he decided to leave blanks where he figured maybe some hadn't been discovered yet. And as an example, gallium had not yet been discovered by the time of Mendeleev. He was able to, it should have properties similar but increasing between aluminum, indium, and zinc and germanium. And when the person said, hey, I think I've discovered gallium, but it wasn't what you predicted as far as how dense it should be, he said, well, go back and check again. And then it was, and they knew that this was his table was a good one. So what do we now have? Well, the common periodic table is all the elements arranged by atomic number, not by atomic mass, although in some cases it's pretty close. And every single, just some basic things that you'll need to know is that the groups or families are the columns, and these are groups of elements, and this is what Mendeleev came up with, that have very similar properties. That's why they're called families. So all of the alkali metals they're some of the most reactive metals. Alkaline earth metals also are somewhat reactive. Then you have transition metals. Over here we have the noble gases right here, the halogens, and then typically at this point we call like the oxygen family, the nitrogen family, and so on. So just remember, if this were the periodic kingdom, again, same columns are the same families, elements that have very similar properties. Now, what are some other features of the periodic table that are so important? Well, generally speaking, the metals are on the left side. The non-metals are over here on the right side. A couple other things is you see these elements sort of right here, which are kind of what we call metalloids. They can't really make up their mind if they're metals or non-metals. We talked about the names, and you can see some of those down up here. One of the things, and later on, Glenn Seaborg pulled these out. These are the lanthanides and the actinide series. A lot of these are very radioactive, and most of these are made. You can only find them if you make them in a lab. Okay, so that's some of the just the periodic table sort of 101. These transition metals tend to have delocalized electrons, which are the Ds, and they are used a lot in construction and making jewels and things like, or making stuff that we wear and rings and things like that. Okay, so now let's take a quick look at the electrons. Okay, so if we look at the orbitals, there's some really cool patterns. If you take a look at the quantum numbers, all of these right here, again, is what's called the S block. If you look carefully, these all end in S1 and S2. So this really fits, again, an amazing pattern. And the pattern is, it's the period, which is the same as the energy level, and then S1 and S2. So if I just go to calcium, I would know that, hey, it's the fourth period or fourth energy level, S1 and S2, and that's what it ends in. All of these over here is what we call the P block. Notice for any one Like krypton, it ends in 4p6. Again, 4 is the period, and then the energy level is the fourth energy level. It ends in p. S. Again, this one ends in 3s, or I'm sorry, 3p4. That's for sulfur. So these all end in p's. And one of the things I should mention too is that we called the columns our families, but we're calling the rows going left to right are periods. And then the transition metals, these all end in D's, okay, and these all end down here in F's. And again, what we tend to find is that this is an incredible. I mean, they made Mendeleev had no idea about S's, P's, D's, and F's, but we see it fits a really great pattern. The most important thing are the properties. Okay, when we look at the properties, here's the thing that's incredible. So let's take a look at, for instance, size. That's an important one. Now we're going to spend quite a bit of time on Coulombic attraction, and that's what influences how one charge, like a positive nucleus, can affect pull on a negative charge like electrons. Now the nice thing about this is it shows us general trends and patterns, and when we look at the general trends, as you'd expect, going from top to bottom of a family, the size tends to get larger. So for instance, the radius is 298 for cesium, but for lithium it's only 167. Now let's go left to right. This is a little bit unexpected. In general, and again this is very general, as we go left to right, potassium starts off at 243, and then surprising, bromine is down to 94, and that's picometers. And so what's a little surprising is that in general, the size gets smaller going left to right. And that's not always intuitive, but if you think about it, we're putting, for the most part, in this P section here, the electrons are being put on the same energy level, but the nucleus is getting bigger and bigger and bigger, that positive charge, and it's pulling harder and harder and harder. Then, when we go down to the next level, you're going to a whole new energy level and a whole new floor, so of course it's just going to get bigger. So left to right generally gets smaller. Top to bottom, it gets bigger. And this is why we call it the periodic table, because what we see is that these properties tend to repeat periodically. So it goes from big to small. We have a non-metal here. Then we go back over here, goes back to being larger and a metal to the non-metal and so on. Now let's just look at a couple other properties. Here's one, ionization energy. As a general rule of thumb, again, the ones over here, metals, for instance, going top to bottom, ionization energy gets much smaller. The electrons are much farther out. You have less control. Going left to right, in general, the ionization energy goes way up. Why is that? Because again, which is the energy needed to pull off that electron. Non-metals don't want to give up electrons. The electrons are much closer. Again, it's smaller, closer to the nucleus, and it has more, and we're starting to fill up the energy levels. Couple other properties, and again, here's one that I think is pretty cool. Let's look at density. Okay, if we just look at density at standard temperature and pressure, here's what Mendeleev found. If you look at boron, again, it goes to 2,460 kilograms per cubic meter. Then it goes up with aluminum, and then you see here it goes even higher with indium. So you would expect, and here's the power of the periodic table, that if aluminum is 2,700, indium is in the 7,000s, this would be somewhere in the middle. Also going left to right, let's just do a quick check. Cobalt, 8,900, 8,900, 8,900, going down there, and then over here it goes down. So this would be somewhere between 7,140. Gallium would be 7,140 and 5,000. So again, we know that the density of gallium, which by the time of Mendeleev had not yet been discovered, would be somewhere in between. So if we check it, sure enough, it's about 5,904. And so what we tend to find is that these properties are like this. I mean, this happens all the time with all these properties. So just to recap, periodic table, it's all about trends and patterns, go to this site. You need to check out the same ones with electronegativity, ionization and energy, how dense things are, and their general properties. My name is Chad Houston.